The LeetCode problem we are going to solve now is called Dota2 Senate. This one is a medium problem, and also in this problem we are going to play a game between two political parties. First one is called Radiant and second one is called Dire. But for simplicity, throughout this video we are simply going to refer to them as Republicans and Democrats. If you want, you can read through this whole statement, or let me quickly explain you the rules. So the problem statement is, we are currently given bunch of different senators that are present in a simple queue, and each of them is going to be doing a vote. Now in this vote, each senator belongs to a different party. So we have some senators that are currently representing Democratic Party, and then there can be some other mix of a bunch of different Republican parties, but overall it's going to be either Democrat or Republican in whatever sequence. Now the thing is, we need to determine that which party is going to win. Now how would a party win? Basically, any single senator who comes in to vote, that senator currently has two abilities. Number one ability is that that senator would be able to kill someone's vote or get rid of some senator from the other party. So let's say that if this guy is a Republican, then this person can kill or get rid of a Democrat vote. So that Democrat would not be able to vote, and vice versa is also true. And second thing this senator can do is that if there does not exist any other person that they can eliminate, then this person should be able to declare victory. So let's try to understand that how this is going to work. And also the voting is going to keep on continue until there are existing senators present. So if one senator has done the voting, and if that senator survives, that senator basically moves to the back of the queue, and then voting would continue. So let's try to understand this with an example. Suppose we are currently given a sequence like this. This is a very small sequence. So what is going to happen? The first person currently in the list is a Republican person. So this Republican senator knows that there are more people currently present inside the given queue. That Republican senator also knows that they need to eliminate one Democrat, and that should be like the immediate first Democrat that they can find. Okay, so the first Democrat that they can find is going to be placed over here. So they are going to get rid of this Democrat, and what is going to happen is that then this Republican casted their vote and they cannot declare their victory because there are still more Democrats. So they are going to go to the back of the queue. So this is the initial position, RDD. Then after round 1, basically we would have this guy eliminated. So we would have a Democrat and a Republican, because this Republican goes back and this Democrat comes to the front. And after round 1, now once again it's Democrats' turn. So once again they know that there exists a Republican, so they will get rid of this Republican and then join the queue again. So in the round 2, we would only have one Democrat left. And at this moment, we should be able to see that because it's only one Democrat, there is no one else to eliminate, then this guy is going to declare victory, and this is what we need to return. Now let's try to take one more slightly longer example. Okay, so let's say that we currently have 3 Republicans, then 4 Democrats, and then let's say we have one more Republican. Okay, so in this case, what is going to happen? Now logically it seems that the voting is divided fair and square, but let's see that how would things change with each different turn. So first turn is this Republican guy's turn. So he knows that this is a Republican, this is a Republican, he won't do anything, but this guy would get eliminated and then he would go back to the queue. So now we would have 2 Republicans, then 3 remaining Democrats, and then once again 2 different Republicans. After that, we will have one more Republican that would be able to kill or eliminate one more Republican. So basically we would have 1 Republican and then 2 Democrats, and then once again 3 different Republicans over here, because this guy would go back. Once again this Republican would get rid of this Democrat. So and then they would jump to the back. So next round we would have 1 Democrat and then we would have 4 different Republicans. After this one, this Democrat would get rid of 1 Republican. So now we would have this Democrat would go back, and then we would have these 3 Republicans and then 1 Democrat. And now this guy is going to get rid of this this Democrat, and in the end we are going to be left with 3 Republicans, and so they are going to be declaring the victory. So this is the whole solution or the whole problem statement. Now let's try to understand that how would we solve them. So at a very basic level, if we are only given, let's say, a simple scenario where we are given bunch of different possibilities, what is going to be the brute force approach that we can take? Well, it's quite straightforward. Number one thing we are going to do is, for each Republican or each R, we would have to keep on going into the remainder of entire queue until we find a D. If we find a D, we will basically eliminate this D, or somehow find a way that this D should not be counted based off of its index value, and then we would put this guy back. So then we would have a shorter string in the next round. So once again, now we are going to R, R, and then D, 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 and once again this R, because this R goes back. And once again, we are going to repeat the process. Now, what is going to be the complication part? For each of the element, we would be scanning all the remaining elements, and we would be continuing doing that for all the different elements that are present. Now, slowly we are reducing the size of our queue, but overall it's still n multiplied by n work we are doing. So this is going to be the worst case scenario, that this is how we would be able to solve this problem. Now let's see that is there a way we can make things faster in this existing scenario? Well, if this was straightforward voting, where we could just majority only wins, then we could have simplified in just one simple iteration. We would just go over this entire exercise and then try to find a place, whichever has the higher number of votes basically declares the wins. But this is not the case here, where if we let's take an example like this, that in this case we only have 2 Democrats and 3 Republicans. What's going to happen? This Democrat is going to eliminate this guy's vote and then would go back. So we would have D and then RR and then once again D. Then once again this Democrat is going to eliminate this guy's vote. So once again we are going to R, D and D. So now this Republican can eliminate this guy's vote, but once again we would have D and R, and then this Democrat would be replacing this Republican's vote. So notice that even though we only had 2 votes over here out of 3 votes, still these guys win because of just sheer positioning. So a simple fall through would not work. What would be the approach or optimal way we can solve this problem? Well, we can solve this problem using 2 queues in this case. Now, how would we use 2 queues? Let me give you the whole solution. We'll try to walk through it. Let's take the example. Let's say that we currently have this kind of scenario, and let's see that who is going to win. Okay. Now, we know that this what is their current positions in terms of location. We can mark them out. So let's just mark the index values, that where they are currently located. And at the same time, we are also going to keep track of them in 2 different queues, and each queue is going to represent one party. So we would have one queue that is simply going to represent the Republican Party, and then we are going to have another queue that is simply going to represent the Democratic Party. And for each of them, we will have the positions of the queue located, and based on that we would decide that whether one should stay inside the queue and come back, or should they be eliminated. Now we know that queue follows the principles of FIFO, first in first out, and we are also going to be utilizing that in quite heavily. So let's start creating our queues. So, and we would be entering just the index positions in the queue. Okay, so currently we have Democrat and Democrat sitting at position 0 and 1, so 0 1, and then this Democrat is sitting at position number 4. So let's just put it over here, and then we have 2 3 and 5. So let's just put it over here. Now let's see that how our queue is going to work. First of all, we are going to be fetching both of these entries, and we would only pick the smaller entry. So we know that amongst 2 and 0, 0 is the smaller, which means 2 would be eliminated. So we would simply get rid of 2. So 2 would not be present anymore. But now with the 0, this 0 is going to the back of the queue. And what is going to be the back of the queue position? Basically, with every single size, the size of the queue shrinks by 1. So that's what we are going to put. So in this case, after this elimination, because we get rid of this Republican guy, now the position of this queue is queue becomes instead of 6, we would have 5 elements, and this D is going to go to the very last element. So that element number is going to be 4, like index value is 4 and the position is going to be 5. So we would have 4 coming to the back of the queue. Okay, and at the same time this 0 would be eliminated from the existing queue. Now the same operation would get repeated amongst these two values. So amongst 3 and 1, once again 1 is smaller and 3 is larger. And notice that we are also keeping track of the current size of the queue. So this time the size is going to 4, the next time size is going to be 3. So the whoever gets added would be this entry would be added in our queue. So now amongst 3 and 1, because this 3 is larger, we can get rid of 3 because we don't care about it. And now this 1 is going to come back to the queue by becoming the value number 3. So let's rearrange these values, 4, 4 and 3. And then this guy is still 5. That is what the position is. Okay. Now, since we eliminated both of these guys, so notice that in the original queue, these two guys eliminated these two guys. So now we only have this D remaining, and they are trying to eliminate this R. And once again, this guy is going to eliminate. So comparing 4 to 5, once again, this is going to eliminate value number 5. So now this entire Republican queue is completely empty, and this the size of our queue is going to become 3 once again. So index position is going to be 2. So this guy would get eliminated and it would come back to the queue as value number 2. But now we don't have anything to compare against in the second queue, so we can simply declare this Democrat as victor, and this is the whole solution basically. Now I hope that the logic made sense to you, that how we were able to solve this problem. Let's try to talk about time complexity in this case. The time complexity is going to be big O of n, because we are simply iterating over this given queue once, and then we should be able to basically come up with the solution very quickly. So more or less it's not going to be like n square, it's definitely going to be smaller than that. In terms of space complexity, this is also going to be big O of n, or big O of because we are using two queues, that is going to be the size of all the number n present probably. So once again, this is the whole solution, and I hope it makes sense. Now let's see the coding approach for this one. And by the way, in this case, throughout this program, I refer to them as Republican and Democrat. There is no political implication. I'm just trying to explain it in simpler terms instead of using terms like radiant and dire. So yeah, this is what the problem was. So let's see the coding solution now. So the coding solution is quite straightforward. We are first of all going to define that what is the current length of our given Senate string, and then we are going to initialize two queues, one named R and the other one named D. For both the queues, we are going to iterate over the given string, and then we are going to keep putting the value in either R queue or the D queue that we have created. Now we are going to simulate different rounds, and our basic condition is quite straightforward, that until one of the queue is not empty, just keep on polling both the numbers from both the queues, and for each of the position, check that which queue is currently present that has the proper value, or that can eliminate the other value, and then either get rid of that value, and the remaining value would go back to the existing queue, and we would keep repeating this process. Now in the end, we are simply going to check that whichever the queue is not empty, basically we are going to declare that as the vector. So let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And our code runs beautifully, beating almost 73% of all the other solutions. It's also pretty good in terms of space complexity, and the solution is present in our GitHub repository, so feel free to go and check it out from there. Thank you.